Hello, today we're going to look at rationalizing the denominator for these expressions down here, for these surds. Now before we do that, I'm going to go into the technical definition of what a surd actually is. And these are examples of surds here. I'm going to come back to that in a moment. Now, before we get on to the definition of a surd, actually no, I'll just define it now. The definition of a surd, a technical definition, is an irrational root. Now, before I get on to looking at that technical definition, I'm going to define what a rational number is. Well, a rational number, this is an example of a rational number. 6 is a rational number because it can be defined as a fraction or a ratio, where on the numerator and on the denominator the number is a whole number. So 6 can be defined as 12 over 2. It could also be defined as 18 over 3. So a rational number is a number that can be defined as a ratio or a fraction where the number on the numerator is whole and the number on the denominator is also whole. Also whole, I should say. Here's another example. 8.2 can be defined as 82 over 10. So it's a rational number. A pretty famous number that you've encountered so far in your maths would be pi. That's 3.14, etc, etc, etc. That is irrational. It cannot be defined as a fraction with a whole number on the top and a whole number on the bottom. So that is irrational. Now surds are what we call irrational roots. In other words, these surds here cannot be defined as a fraction with a whole number on the top and a whole number on the bottom. Now, so far we've only really looked at square roots, but surds can also be cube roots, sixth roots, whatever roots could be the 20th root. So these are examples of surds. Now, the surds that we look at, we just tend to simplify them or just tend to look at square roots. And we'll do that in the case down here. But just remember, technical definition of a surd is an irrational root. Right, now to this. Rationalizing the denominator. Now at the moment our denominator is irrational. It's a surd, so it's irrational. So what we do to make it rational is multiply both the numerator and denominator by root 5. So multiplying the fractions on the numerator, 2 multiplied by root 5, and on the denominator the square root of 5 multiplied by the square root of 5 is the square root of 25. So that simplifies down to square root of 25 over the square root of 5. Now rationalizing the denominator is maths jargon. Another way of maybe phrasing it in plainer English is making the whole number, rather than a surd, making the denominator a whole number, so down here, rather than a surd. So rationalize the denominator for this example. Well, let's multiply by the root 3. 3 multiplied by root 3, and on the denominator 5, and then we've got the root 3 times the root 3, that's root 9. So we get 3 over root 3. 3 root 3 over 5 multiplied by the square root of 9. Square root of 9 is 3. So 5 multiplied by 3 in the bottom. We do a bit of cancelling. Let's cancel out those factors. So cancel out the 3 from the top and bottom, and we're left with root 3 over 5. And our denominator is now rational. In other words, it's a nice whole number if we want to simplify it that way. So please remember, when you're rationalizing the denominator, all it really means is making it a nice whole number, and you're going to multiply by that surd on the bottom of the fraction, on the denominator of fraction. Goodbye, and thanks for watching.